In this video, I'll talk about the drift velocity. Let's say you have a metal, and this metal is at room temperature. Okay, no potential difference is applied. What does that mean? There is no any battery here applied. Okay, no battery. But the the metal has ocean of electrons. There's lots of free electrons. That is, it is in fact moving all the time. The electrons, if you take any metallic conductor, a copper, and if you look microscopically, these are the free electrons, and that all the time are in motion. And in the last video, I mentioned that if the charges, if the electrons are in motion, it produces electric current. So, why does a metal, which is a room conductor, does not have current? The electrons are in fact in motion, so there must be a current. But when you measure it, there is no any current. And the reason is at room temperature, or when there is no any applied potential difference, or when there is no electric field, the electrons or the charge carriers, let's say, are moving in the random direction. Sometimes this might move this way, sometimes this might move this way. So it does not have preferred path to move. And as a whole, the average velocity or the average displacement of the charge carriers is zero. That means the drift velocity is zero. Now I've come to a different term, but let me explain this one more time. So how does the electron behave when it is at normal temperature or at room temperature? So let's say I'm considering this electron here. So at room temperature, the electrons are in motion. So this electron, while moving, might collide with another electron. It might change its direction, so it might move this way. Then this electron might collide with this electron here. It might again change the path, so it might turn back, and again turn back this way, turn back here. And now if you look at this path here, the original path, and the final, it has come to about the same location or along the same line. What does that mean? The average displacement is zero, or the average velocity is zero. So if we just take about all the electrons here, it's doing exactly the same thing. Sometimes it is in motion, no question about it. It is all the time in motion. It's the free electrons. That's why we call free electrons, because they are in motion. So all the electrons are moving, but now sometimes they collide and turn back. So one electron might be moving in this direction, the other electron might be moving in this direction. So there is a random motion of the electrons. So it does not have any preferred path. So that means the average velocity of the electron is zero when there is no any applied potential. If the average velocity is zero, then what we can say, average current is zero. So there is no current at all when there is no applied potential difference, although the electrons are in motion. Okay. So now let's talk about what happens when we apply a potential difference, or what we can say, when you apply a battery, when you supply a battery here. So when we apply a potential difference across a conductor, that basically sets up an electric field in the conductor. So the battery, the only purpose of this battery is to provide an electric field, or to set up a potential difference between these two ends. Okay, so whenever we apply a potential difference, so that means this is a positive terminal. Now let's say this is the negative terminal, and if there are the electrons, then this positive terminal will attract the electrons. Okay, So now we have set up a preferred path. The electrons have more tendency to move in the direction of the field. Okay, so what is the electric field doing? It is setting up a direction in which the electrons have more probability, more preferred path of moving in that direction. Okay, so in this case the electric field is in fact in this direction, from positive to negative terminal. And as this the electron, as these are the electrons will move in this direction, because this is positive, this is a positive terminal, so the electrons will move in this direction. Okay, so the electric field, what the electric field is doing, or what a battery is doing, it is setting up a potential difference, or we can say that it is giving the electrons a more preferred path. Now, while the electrons are now moving in the preferred direction, still there are ocean of electrons, like those electrons here. What is doing now? So these will still will hit or collide with other electrons, with other charge carriers. So this may hit another charge. Again, it might change the direction. But over a long period of time, the electrons move slightly in the forward direction, or in the direction of the electric field. Okay, so, or in the direction of the preferred path. So although there are collisions, all the time there are collisions, okay, with the other electrons, but the electric field makes the electrons or the charge carriers to move in a preferred directions. So in this case, over a long period of time, the average the velocity of all the electrons or all the charge carriers is zero. But in this case, there is a certain average velocity. That means if you look after a long period of time, so this electron might have moved to a certain distance. So the average velocity, here I'm talking average velocity with which the charge carriers are moved in a conductor is called the drift velocity. Okay, so it is written here is the average velocity with which the charge carriers move in a conductor. Okay, and now you might have understood why I'm calling this average velocity. All the time the velocity changes. It could be changes because of the magnitude, because the direction is changing all the time, and the speed also changing whenever it hits another electron. The direction, the magnitude changes. That's the reason we define the average, the velocity. So with this potential difference, there is a net effective average velocity with which the charge carriers move in a preferred direction, or in the direction in which the potential difference is applied. All right, so here if this is a positive terminal, the electrons will move in this direction, but the current again will be in this direction. So this is the drift velocity. Again, if you have any questions, let me know. So just to remember, the drift velocity is the average velocity with which the charge carriers move in a conductor. If you have any questions about drift velocity, let me know, or write down your questions in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you.